All right, we're moving on to 5.2. You will notice that we'll do some things kind of out of order of the book and more in the order of what I think is best for Chapter 5. So 5.2, we're going to talk about x and y-intercepts today. So there's your date, and here we go. Before we get into the intercepts piece of it, it might be nice to know that we are working on a chapter with linear functions. What is a linear function? It's a function whose graph forms a straight line. So everything we're looking at in Chapter 5 will be these straight lines, and they are linear functions. An easy way to remember that linear means it's going to form a line is the fact that linear has the word line right in it. All right, but today we're going to talk about intercepts. So if you have a line on a graph, let's take a look at this graph right here. Just a couple of things to point out. You've got your x-axis, that's the one that's horizontal. Your y-axis is that vertical line. And if you were to have a linear function, so some line on your graph somewhere, there's your bell. This is going to be this red line right here. It's going to cross your x-axis and it's going to cross your y-axis. And these give us x and y intercepts. So an x-intercept is where your line crosses the x-axis, right there. And the y-intercept is where your line crosses the y-axis. So how do you find your x and y-intercept? We're going to find these using some math. If you're looking at a graph, like the last example, you can figure out the ordered pairs. If you're looking at an equation, here's what you do. You just take the equation to find the x-intercept, you plug in a 0 for the y, and then you solve for x. So that's coming from, let's say this is our x-axis and our y-axis, and we've got some line on here. And the x-intercept is going to be right here. Well, that ordered pair is going to be, you go over to the right, however many, blah, blah, blah. That's your x value right there. So you've got your x. And then do you notice how we're not going up or down at all? You're just staying right on the axis. That's what makes the y a 0. So each intercept will have a 0 as part of its ordered pair. So how do you find it? Just take the 0 that we know is part of the ordered pair and plug it in for the y. All right, the y-intercept, same idea. You're going to plug in 0, but this time for the x, and then you're going to solve for y. So if we have our x-axis and our y-axis, and you've got a line wherever it might be, let's say it's right there this time, your y-intercept is going to be right here on the y-axis. Again, that's an ordered pair. Well, first for the x, if you notice, we're not going left or right at all, so that x is a 0. All we're doing is going up for whatever the y is, so you have 0, y. So this 0, that's part of our ordered pair, part of our intercept. That's why we can plug in 0 from the beginning to figure out what the x is. Sorry, you can plug in 0 to figure out what the y is. And then just something to highlight, once you have your answer, you have to make sure that you do go back and write it as an ordered pair to get full credit. All right, here's our last side of the intro video, and we'll just look at 2 examples so we can see what we're talking about. So x and y-intercept, first we'll do the x-intercept. We're going to plug in 0 for the y. So whatever intercept you're finding, you're plugging 0 in for the other variable. So this looks like 3x minus 2 times 0 equals 12. And then the nice thing about plugging in a 0 is it makes things cancel away. So 2 times 0 is 0, so that's gone. So really all you have is 3x equals 12. And then you've got a nice little equation to solve. Divide both sides by 3, and we get x equals 4. So it's really tempting to leave that as your answer, the x equals 4. But remember, this has to be written as an ordered pair. So our answer is actually 4 is the x, and we plugged in a 0 for the y, so 4, 0. That is our x-intercept. All right, now our y-intercept, let me move this up a little bit. Same idea, you're going to plug in a 0, but this time we're going to plug in a 0 for the x. So we're going to do 3 times 0 minus 2y equals 12. That 3 times 0 is 0, so that cancels away. When we rewrite the rest of the problem, be careful. Here's where a lot of people go wrong, is this 2y because of that subtraction in front, that is actually a negative 2y. So you want to carry down that negative 2 with it, and then divide both sides by that negative 2. So we got y is equal to negative 6. Now again, we're not going to leave that as our answer. We're going to write it as an ordered pair. We plugged in a 0 for the x, and we know that y is negative 6, so that goes in the y spot. And that's our ordered pair. Those are our intercepts. All right, so one more example for our video. Let's see, move this over a little bit. Now, this one looks a little bit different. If you notice, you have you've got y's in a couple spots. I do think it's easier if you get everything on the same, or get them combined at least, before you try to figure out your x and y intercepts. So on this one, maybe we can just subtract the 2y from both sides to get those together. So you have negative 4y plus x equals, and then let's catch that as a negative 8. So we're going to find the x and y intercepts of this equation. X-intercept, plug in a 0. We're going to plug in a 0 for the y. So negative 4 times 0 plus x equals 8. Well, that cancels away, leaving us with x equals 8, and there's your intercept. 8, 0 for the y. Y-intercept, a little line. All right, our y-intercept, we're going to plug in a 0 for the x this time, so negative 4y plus 0 equals negative 8. Your 0 is just 0, so really we're looking at negative 4y equals negative 8. Divide both sides by negative 4. Y equals, now careful here, if you notice you have a negative 8 over a negative 4. Anytime you have a negative number divided by a negative number, it does come out positive, so that's going to be a positive 2. So our intercept, the x was a 0 that we plugged in, and we got back a 2 for the y. And that's how you find your intercepts.